Hello, class, and welcome to combined lesson 7.1 and 7.3. At this time of the year, folks, we're almost done our course. We're going to take a short, 2 or 3 lessons in Unit 7 and combine it with Unit 8 to make your last unit test. And again, check with your teacher or check with the website to see when that upcoming test is. Okay, so for start off with warm-ups, folks, number 1 says to identify as many triangle types as you know and draw a picture of each of them. Okay, so I'll give you a hint. I'll start with one, and it's the most symmetrical one, and that is called an equilateral triangle. Okay, and what do we know about equilateral? They all have the same sides. That's why you give them the same tick marks. And what do we know about a triangle in general, folks? It has 180 degrees. And an equilateral triangle, not only are all the sides the same, but also all the interior angles are the same. So if you take 180 degrees and divide it by 3, you know that each angle, ladies and gentlemen, they're going to be the same, and they're going to be 60 degrees. Okay, so that's one type of triangle. I would like you to pause the video and try the rest. Okay, so I'm going to pause the video, and I want you to figure it out on yourself. Try as many as you can, okay? All right, class, welcome back. Hopefully you filled in as many triangles as you could come up with. Again, we reviewed the first one. Let's take a look at the second one. The second was an isosceles triangle, which tells you that 2 sides of the triangle are the same, and therefore the 2 base angles will also be the same. A scalene triangle, ladies and gentlemen, is where all 3 sides are different lengths, so that's why you have different tick marks. And if you wanted to express that if all 3 sides are different in length, then also should your angles. Okay? All right, taking a look at one triangle. Hopefully you remembered is a right triangle. A right triangle has a 90 degrees, which is that box. Okay, and I'm going to go right away to introducing a new triangle you probably haven't heard of. It's called an oblique triangle. We're going to use it upcoming in the trigonometry unit. And an oblique triangle is the opposite of a right triangle. It has no 90-degree angle. Okay, so an oblique triangle could be either acute or obtuse, where all the angles inside are acute, meaning they're less than 90, or an obtuse triangle is where one angle is greater than 90 degrees. All right, so that's taking a look at the warm-up for 7.1, and 7.1 deals with congruent triangles. So we're going to take a look at that. 7.3, on the other hand, is what we call similar triangles, and similar triangles is going to be comparing one triangle to another. So we're going to have one ratio related to another, and we have to remember, how do we solve when we have what's called an equivalent ratio expression? Okay, so taking a look at this first example, ladies and gentlemen, some of you might be able to do this by inspection. I'll show you what I mean by that. Would you multiply 5 by to get to 10? You multiplied it by 5. Whatever you do to the bottom, you do the same to the top. So 1 times 5, x equals 5. Okay, that's one method to do it. Or, okay, a method that works every time, which is called cross multiply. Okay, so to cross multiply, you take your variable with the opposite diagonal, so 2 times x is 2x, equals the opposite diagonal, which is 1 times 10, which is 10, and then to isolate the variable, folks, you divide both by 2. And again, folks, you're already almost done grade 10 math, so you don't actually need to show me that step, but if you need it to help you, by all means, put it in. All right, so I want to let you know, folks, that the first method we talk about, which is called inspection, it only occurs when you have an equal amount to do that. So, for example, if I just skip to number 3, what number does 5? What number do you multiply 5 by to get to 7? Well, there is no even number, so that's why inspection does not always occur. It only occurs when you have even multiples or dividers. So we always can use cross multiply, and only sometimes can you use what's called inspection. So I'm going to just keep on with my cross multiplying for now on, okay? So I'm going to take a look here. I got 4 times x, which is 4x, equals 2 times 12, which is 24. Again, to get x by itself, divide both sides by 4. So x equals 6. And I'm just going to throw in here units, because eventually we're going to have a measurement attached to it. So I'm going to hop back to A and just put units down. Because when we get into our triangles, each side length that we're going to be comparing will have a unit of measurement. So let's just write down units. There we go. Now taking a look at C. C might look a little different, and it says, hey, AB. That's just measuring A and B are 2 points on a triangle, so that's length AB. Just remember back from our distance formula, that's what we used. So we do the same thing here, folks. We're going to cross multiply, so 5AB equals 3 times 5, which is 21. To get AB by itself, you divide by the coefficient, which is 5. So AB equals 21 over 5, or you could write down that it equals 4.2 units. All right, now the last one looks a little tricky, and I want you to get used to this, because when we get to doing our similar triangles, each triangle has 3 sides. So we're going to be comparing, for example, the top side on one triangle is going to be related to the top side on the second triangle, or the bottom side of one triangle is going to be compared to the bottom side of another one. So remember, there's 3 sides in a triangle, so we're going to have a ratio here that looks like there's 3 different parts to it. So this would be one side here, side 2, and side 3. Okay, if you want to think about it that way. Looking at each of these, folks, you notice now we have 2 unknowns. That makes it more difficult. But what we're going to do is we're going to focus on C side 2, ladies and gentlemen. Notice that it has both a value for the top and the bottom, which means it's a given value for both sides of those triangles. So what we're going to do is relay, and we're going to use that for the first one. So we're going to find y using the red box, but we're also going to use 2/7 to find the x using the green box. So we're just going to relate 2 of them. So you only need 2 of them to solve, and we're going to do exactly what we did for A, B, and C. So let's find x first. So we're going to go find x. So we're going to cross multiply. So it's going to be 7 times x. 7x equals 2 times 5, which is 10. To get x by itself, you divide both by 7. So x equals 1.4 units. Okay, doesn't matter what order you do this in, folks. So if you did y first, no big deal. Okay, I'm going to find y now. So to find y, we're going to use the red. I'm just going to change my color, folks, so that it matches up with that in case you're printing this off in color. So I'm going to go find y. So we're using the red box now, folks. So I do my diagonal here, which is going to be 2y equals the opposite cross, which is 21. Okay, divide both sides by 2. So y is going to equal 10.5 units. All right. So now, ladies and gentlemen, what we're going to do is we are going to take a look at 7.1. So today we're going to be dealing with both congruent and similar triangles. So got to make sure we know the difference between congruent and similar triangles. Let's start by filling in some of these blanks. Congruent triangles have equal corresponding sides and equal corresponding angles. Okay, so you will see this a lot if you look in a house, the tiles on the floor, right? If you happen to have triangular tiles or some type of mosaic that has triangles in them, you're going to see this, okay? Big thing to think about in construction, folks, when you're doing trusses of a house, which are the supports that build roofs. You'll notice they're triangular in shape in most cases, and you're going to have several of them in a row to make the full roof supported, right, properly. I believe you have to have them either every 12 inches or 18 inches. You have to have your trusses equally divided. That's a question to ask Mr. Zacher for sure. Okay, so what we want to remember, folks, is that if we've got 2 triangles, in this case we've got triangle ABC is congruent to triangle DEF, we write, and I want you to take a look at this in this specific symbol here. Triangle ABC is congruent, which is an equal sign with a tilde on top. Okay, if you're looking for on the computer where you find the tilde, folks, that's going to be right beside your number, to the left of your number 1 key. Because I know some people aren't familiar with that tilde, but it's on top of an equal sign. Okay, so that means congruent. And notice, folks, that these are in order. And what I mean by letters in the triangle description, AB, they're going to be equal to DC. So the first two of the first triangle and the first two of the second triangle, they equal, which is this one right here. Okay, then we take a look at the last two. So BC is equal to EF. Okay, and then I take the last and the first, so it's going to be CA and FD. They are equal also. And what that represents, folks, are those just side lengths. Okay, so the sides are equal. Okay, the angles, I'm not sure if you remember this from elementary school or not, or even grade 9, but when we describe angles, we use 3 letters. So when we say triangle ABC, we're looking at B, the angle B. So we go from A to B to C. So it's that kind of angle right there. Okay, and that's going to equal angle DEF. Okay, and angle BCA equals angle EFD. Notice they got the same symbol. And angle CAB equals angle FDE. Now notice I just wrote in those angles. I'm going to try to erase it. You don't actually need that, folks, because if 2 angles in a triangle are the same, then the third one also has to be the same, right? By process of, because they both equal 180 degrees. Awesome. Okay, so there are 3 conditions that allow for congruent triangles. And these are short forms, folks. So the first one is side, side, side. So all 3 sides are the same. And if all 3 sides are the same, then guess what? All 3 angles have to be the same. Okay? Then we have what's called side, angle, side. And I want you to just note that this is what we call a contained angle. Okay? It's another word of saying that. But side, angle, side in a row. So any side with an angle and then the side right beside it. So the angles contained, meaning both the sides that meet at that angle are given. Okay? And the other one is, folks, angle, side, angle. Because if 2 angles are the same, guess what? So must the third one. All right. So those are the conditions. Okay? Let's take a look at similar triangles and see how they differ from congruent. Okay? Similar triangles are different than congruent. If you take one triangle and you either shrink it or enlarge it, then you're going to get what's called similar triangles. Okay? One thing to remember about similar triangles is they have equal corresponding angles. But what's different, folks, if we shrink or enlarge one triangle to get the other, we do it in a proportional ratio way. So if you look here, folks, we've got a proportional ratio, which is just kind of like that last warm-up question we did. Okay, so we're going to write in proportional ratio. Okay? And ladies and gentlemen, those are words you need to know. Proportional ratio sides. So for example, if AB in my diagram, folks, just take a look at it. If AB is 3 times the size of DE, same with BC must also be 3 times the size of EF. So whatever you shrink on one side, you shrink on all the sides. Whatever you enlarge on one side, you do to all of them. This is where you talk about scale. So if you've taken geography, folks, and you see a scale diagram on a map, okay, the actual versus the diagram are different. Okay, one's bigger than the other, and that allows that to happen. Okay, so similar triangles, ladies and gentlemen. The difference here is, take a look at the sign. It is just a tilde. Again, you always have the same order. These are written in order. So triangle ABC is similar to triangle DEF. And we have a ratio that's proportional. Okay, so just like the warm-ups. Okay. And the angles are exactly the same in both congruent and similar triangles. They're always the same. Okay. So proportional ratio is what I want you to remember. This is just an interesting fact. We won't be worrying about that, but that's kind of cool. This is a cool fact. Okay, that if the area of similar triangles are equal to the square of the ratio of their corresponding sides, you may like that if you're into engineering and design. That's a cool thing to remember. All right, so let's do some work with trying to find out some of these triangles, okay? Given that triangle KLM is congruent to triangle RST, determine all the missing measures. So remember, that sign means congruent. Okay, and for congruent, you want to know that equal sides equal angles. Okay, so all we have to do is figure out and match these up. Okay, sometimes your triangles are twisted, turned, flipped, so it's not always the easiest to find the matching angles. Okay, so I want you to take a look. What we need to do is to determine all the missing measures. So we got to find side lengths and angles. So first of all, let's take a look at KL. So KL goes from a blank angle to 35 degrees. So match that on the other side. You're going to have it being RS. Okay, let's go for what information is given. So we know KL is already given us 7 centimeters equals RS. Well, hey, that's one of our missing measurements. So we've now found it. Okay. Okay, next side length that we're going to take a look at, let's do LM. Okay, and LM is going from a 35 angle to an 80 angle. So what does that match up here? That matches up S to T, and yes, you have to have the order. It can't be LM equals TS, it's ST. Okay, because it's both the 35 degree angles start first. Okay, all right. And what do we know? We know that LM is 5 centimeters. And ST equals 5 centimeters. LM was blank, folks. I forgot. Let's just put LM in there. I was looking one line down. Okay, so there's another measurement we found. Okay, now let's take a look at the last one. The last one, ladies and gentlemen, is KM. So I'm going to go from blank to 80. Okay, which is going to equal RT. Okay, now KM is given as 3 centimeters equals RT, which is not given, so now we know how much that is. Again, congruent triangles have the same side lengths. Okay, so we found all the missing sides. Now we got to worry about the angles. Okay, so I'm going to change color here. So angle K LM equals, take a look at that angle, folks. That's going to equal angle RST. Okay, and what angle does that equal? That equals 35 degrees equals, sorry, I'll just go 35 degrees equals 35 degrees. Okay, those are both given, so that's okay. Okay, I'm just matching them up so you know. Okay, next angle we're going to take a look at is angle LMK equals angle STR. Okay, so 80 degrees, that was given, equals 80 degrees. Now the last one, we got to figure out how to find this out. So our last matching angle is MKL equals angle TRS. And they're both blank, folks, but what we have to remember is the property of a triangle. It has 180 degrees, and we're going to subtract the given angles. So we're going to subtract 35. We're going to subtract 80 degrees. So that angle equals 65 degrees. You may remember the short form from grade 9, angle sum triangle theorem. If not, let's just put that down. Some of you may have remembered that, or some of you may not. So what does that tell us? That tells us that therefore, this equals 65 degrees, and they're both the same. Okay, so now we have all missing side lengths and all missing angles, and now we can move on to the next question. Take a look here at the difference between this question and last question. It says, given that KLM and RST are similar. Okay, that's the tilde sign is just similar. What does similar mean, folks? Equal angles, but corresponding side lengths are in what's called a proportional ratio. Okay, and it says to determine all missing side measures. So we don't really have to worry about the angles, but the angles help us set up our matching sides. So just want you to remember, guys, that this is proportional ratio sides. Okay, so first of all, let's take a look at KL. Okay, so I'm going from 39 to 82. That's going to be over the corresponding side, which is RS. Equals. Now I'm going to go L to M, which is 82 to blank, so that's going to be S to T. Okay, and then to my last side, which is my bottom side, K to M, which is 39 to blank, which is going to be over 39 to blank, which is RT. Okay, once you've set that up, folks, then you just need to enter the information in. Okay, so enter the side length, the information in that we have. So KL is 16.8 divided by RS, and RS equals 12. So there is our given ratio that has the information on both sides. Okay. So what do we have here, folks? We have LM doesn't have a measurement, but ST does, of 8, equaling KM, which is 21, over RT does not have a measurement. So we need to find LM and RT. Just give me 1 second, folks. I got to move that homework down because I won't have enough room. So if you want to get your calculators out while you're waiting for me, that'd be awesome, guys. And it won't be too much longer. We're almost done. Okay. All right, so let's take a look. Okay, so we have our ratio that has the given amounts in it. So let's find maybe LM first. So to find LM, I'm going to use this ratio and make it equal to the one that has the given value. So LM over 8 equals 16.8 over 12. Cross multiply, so you've got 12 LM equals, other diagonal cross, 134.4. To get LM by itself, you divide both sides by 12. So LM equals 11.2, don't forget your units, centimeters. Okay, so there's one answer. Now we're going to find the other answer. So we're going to find RT by taking the ratio that has RT in it and comparing it to the one with the given values. Doesn't matter which one you put on the left side or which one you put on the right side. I'm just going to go 21 divided by RT equals 16.8 divided by 12. Cross multiply just like we did in the warm-ups, guys. 16.8 RT equals, opposite cross, 21 times 12 is 252. To get RT by itself, you divide by 16.8, and yes, you'll need your calculators for this one. Okay, and RT equals 15 centimeters. And there's your second missing value. So now you've solved all the missing side lengths. So all you have to do, folks, is take a look at the question. One night's homework is going to be similar triangles. One night's homework, one page here. This is probably going to be your similar triangles. Sorry, I apologize. First we'll do congruent, I think. Order, it should be congruent. Okay, and these ones are going to be similar. Okay. All right, folks, have a great day, and see me if you need any help. Ciao, Bella.